Okay, hello there guys, welcome back to another LibGDX video game tutorial. So in the previous video we improved the input of the game. Um, However, when I ran the game on mobile, I found that the collision detection is still suffering on mobile devices or smartphone devices. That's because the processor on these devices is very slow compared to PC. This is a Core i7 PC, so it runs extremely fast. So the operations we are doing here, might take fraction of a second, while on the device itself it will take a number of minutes probably, based on the operation, of course. So I will explain to you the problem that's happening on mobile devices, and then I show you how we fix that. So let's go back. I did everything off screen, but I'll explain what I did to the code. So let's go to the sprite and go to our sprites colliding. Okay, so our sprites colliding here. So basically this is the old code here. Okay, and what I am doing, I am rendering the sprites using the hardware on the device itself. Okay, so here I am having a service, I'm cleaning that service, I am starting a new sprite batch, updating the camera, setting the projection, begin rendering, setting the blending function, and then I render the first sprite. After that, I want to access the pixels on the buffer itself or on the surface. Because of that, I will call the get the frame buffer pixmap, and this function is extremely slow. It will take so much time on mobile devices to process, if that makes sense. Okay, and then I will finish this one. So I finish processing the first sprite, and then I will do the same thing on a different service for the service or for the second sprite with a shift here. I don't know if that makes sense. Okay, so we have two rendering. Okay, now forget about this one. This is not part of the original, so I'm gonna remove it here. Okay, and then I will start scanning the values. I am getting the bytes here, and the original code was that if px1 doesn't equal 0 and px2 is not 0, at that point dispose the two pix maps and return it true, otherwise keep looping, and if all is if this part does not get executed, then there is a return false. Okay, so the problem here, as you can see, that each time we want to check a collision when the objects are very close to each other, we are rendering the two sprites. We have two rendering, then we are making a copy of the images, two copies, and then we are checking the pixels. So this is an extremely high processing check. Okay, now if you think about it, we can actually instead of rendering the values or the sprite each time, okay, based on angle, we can actually pre-render the values and store them in a buffer, so that when we want to check for collision, we could actually check the buffer and use it right away, avoiding the get frame buffer here, get frame buffer pixmap, and the rendering, if that makes sense. Now, before I explain what's going to happen, basically I am going to rotate every object, and based on that I will store a shadow of that object in memory. So I created a very simple program and stored a number of things or rotated objects just to show you what's going on. So here I'm going to select this one. This is the player spaceship. this is the shadow of the player's spaceship. Okay, so I am storing something like this in memory. And for the bullet itself, this is the shot itself. And for the enemy, let me go to the, where is the enemy? Okay, so this is the enemy related at 335 degrees open. Okay, let me go and go back here now. This is the enemy related 315. Okay, so you know, these are different examples for the different sprites, if that makes sense. Okay, so I will store these values, okay, not as pictures, but as byte arrays, which are far faster, have faster access time compared to images or pix maps. Does that make sense? I hope that makes sense. Now let's see what did I do in order to solve this. Okay, so let me go back to Android Studio and let me show you the sprite class. So first I added a number of things here. Now the first thing you notice that I created a static lists of bytes. This is a two-dimensional array of byte. This is another two-dimensional array of byte, and I have list. So each two-dimensional array of byte represents, you know, the rendering of a sprite at specific angle. And I have a list of these because I have 360 different degrees of rotation. That makes sense. So I will create something for this for the blue enemy, for the enemy shot, for the green enemy, for the player spaceship and player shot, and three-head spaceship. That makes sense. Okay, so this is the first thing I did here. Next, I added a number of functions to simplify things. Okay, so basically I created a function get collision map from list, and the job of this function is to return the correct collision map or the image from the array of list. I will show you later on. Here this is not implemented because this will be inherited and this method will be overridden later on. Now the important thing here is that we have this guy, generate collision for 360 degrees. So first, for the sprite, like the player spaceship or the shot or the enemy shot or the blue enemy, whatever, or the green enemy, I am initializing the list of images or you know, the list of bytes for each angle, if that makes sense. And now I will loop from 0 to 360 different degrees. Now I will call another function, generate collision map byte array for sprite, and I pass the angle in. So let me show you this method. It's here. I wrote it in here. Okay, so I am receiving the angle, the rotation angle. So I will do the same work I did with the collision when I check the collision, but you might be wondering why I'm doing it here. Well, basically this will be executed once, okay, when the game loads. So later on we won't have to worry about it. It will slow the game only once, but later on it will not be called at all. So slowing things at the beginning, but later on everything will be so fast you won't feel it. Anyway, so what do we have here? The normal thing, we are beginning the rendering, clearing the buffers, and so on, and then we are rendering the sprite. Now I'm getting a pix map. Again, this is a slow process, okay, and then I'm generating an array of byte, two-dimensional array of byte, array width and collision width. Now the thing here is that for the rendering of the object I used the virtual width and height for the collision surface because I noticed that if I change the resolution it will scale down my objects. I don't know why. Anyway, It might be something to do with the LibGDX library. I didn't read the whole library, so I'm not sure what I'm doing wrong, but whatever. I used the virtual width and height to, create the collision surface. However, when I'm creating the two-dimensional array, I'm using collision width and height. So this is 128 bytes, and this is also 128 bytes. So we have 16 kilobytes. If that makes sense. 1684. Anyway, so I will loop on these bytes and setting the value to 0, assuming that there are nothing here. Next, I get the pixel. Now, the sprite is rendered in the middle of the collision surface, right? So I will, in order to go to the middle, I will go to virtual width divided by 2. Now I am scanning from location 0 to collision width. So for that, I will subtract this as well, the collision width divided by 2, so that I go to the left corner or left side and then move to the right. Now, same thing goes for the right side, in the y-axis. So I'm checking if the value is not 0. I will set the array of ij to 1. So the values are either 0 or 1. Next, now this part is commented. This is what I use to generate the, the files for the images that you saw in order to debug them, make sure that they are being rendered correctly. So here I'm creating a one-dimensional array, and then I will, I am storing the file based on the class name, adding to the angle and .bin at the end, writing the value. Anyway, so I disabled that because I don't need it at all right now. It was just for debugging, and then I will return the array. So this function has a very simple job, as you have seen. It just takes the angle, rotate the object by that angle, render it, okay, and store, the value, the collision values in compact form. That makes sense. Anyway, so as you can see, we are looping 360 degrees, calling this function. So we have all the 360 possible cases. Now, for angle 0, it will be at index 0. For angle 1, it will be at index 1, and so on. Okay, because we are adding this in ascending order, and the first index is also 0, so no problem. We could use the angle to figure out what's happening. Does that make sense? Now let's go to the let me show you where we are calling this initialization. That makes sense. So let's go to the player spaceship. So I added this function. Where's that? Where is it? Render. Okay, so here, this is the get collision map from list. So in the sprite class, which is the basic class, I didn't add implementation. Here I am adding this implementation, very straightforward. Basically, I'm getting the value of angle and making sure that this is an integer, because a list is being indexed by integer value and the angle is a float. So there might be small errors in the angles, but it is negligible, so no problem. So I'm just checking if for any reason I have an angle in negative value, I will add 360 to have the positive, and just checking if I am using the modulus 360 to make sure that the value of the angle is between 0 and 359. And then I will access the list and get the array of bytes representing the collision map for that specific angle for the collision map player spaceship. Okay, so another thing here is that if we go to the constructor, where's that? Where is the constructor? Okay, so this is a constructor. I added this line here. So if the collision map player spaceship equals to null, this is a static member. So if it is null, just generate collision map for 360 degrees, my case. Okay, very straightforward. Same thing here goes to the player shot, as you can see, and also same code. Yeah, Same thing here. Just notice that I'm using collision map player shot here. Okay, same thing for the enemy shot, if that makes sense. Same thing for green enemy, as you can see here and here. Same thing for a blue enemy here and here, and three-head enemy here and here. Very straightforward. Now let's go to the most important thing. How did we implement a new method for collision? Okay, since I explained everything here, actually I'm gonna remove this code because now everything works at a much faster rate, and so we don't need this legacy code. Okay, because now we know what we are doing. So if A and B are colliding, all we have to do is to get the collision map for A and B. So here I'm calling get collision map from list. So based on the angle, this function will return the correct collision map for A. And also for sprite B, this will get the correct collision map. Also, the dx and dy are float values representing the difference. I will convert them to integer values. Now I will loop on the collision maps. So I'm checking here if the index at ij doesn't equal 0, meaning that there's a pixel in sprite A. I will update the indices here for sprite B, okay, because they are both rendered at the center of collision map. However, there's differences in location between the two, so dx and dy will help me understand where they are located. So I'm adding ddx and ddy, which represent dx and dy in integer values, and I'm just making sure that the indices actually are still inside the array of the sprite B, okay? Because you know, if you are touching from the side, the other indices will be, you know, beyond 128, or sorry, less than 0 or beyond 128. Okay, you can check this on paper. I don't want to confuse you more with that, but anyway, so we are checking things. So now if the pixel here is not 0, so we know that this one is not 0, and this one, the pixel at the same location, you know, if they are shifted correctly to be, you know, at the correct location. So we have two pixels being set. So there is a collision, we return true. So if we loop on all these guys and we don't get, you know, a collision, we will return false, meaning that, you know, they are not colliding. So now let me show you what's happening, how this one is working. Okay, so you can see here there is a small, you know, halt. Okay, and this is a fast machine, so this is not good. There's some delay, and the reason for that delay is that the game is generating 360 different rotation collision map, 360 collision map for the player. So when I press this one, another 360 collision maps are generated for the red enemy, and when I press space, another 360 collision map for the player shot is being generated. Now, does this one work? Well, basically, if you can click here, you can see it is working fine. Okay, and this is actually very fast. However, the problem basically now, we got a new problem, is that we don't want to have this kind of delay when the game starts. Okay, we want the game to run very, very fast. So I won't solve the delay problem right now. I will solve it later on the next video. But the basic idea is that we have one of two solutions. Solution number one. As you can see, I managed to, if we go to, where's the assets folder? Android assets folder. Okay, I managed to generate this at runtime. So this one is generated on this machine, and basically what we could do is to take these files and load them only instead of rendering everything. So we could load these files at runtime when the game starts, and the loading is very fast actually, okay, because we have all these, you know, so we load them right away, resulting in uh, you know, we will never need you know, rendering these objects, okay. We will never need rendering the sprite, so we could just load them right away, okay. Everything will be pre-processed on our machine, so the player will not notice that there's any processing, because actually there is no processing at all. The other solution is that if you have a look at our function for generating the supplies, you can see that we are calling 360 different, 360 rendering, right? Which is a very time consuming. So instead of doing that, we could create a larger surface, okay, and render the sprite in different angles on the same surface. Instead of rendering it at the center, we will render it, you know, each angle next to each other with a fixed distance, okay. So at runtime we will be able to, you know, render one surface, if that makes sense. However, we will render 360, we will get the values and create the surface, and it will be so fast, okay. But there, you know, I think the second idea is better. So instead of rendering 360 for the player and 360 for the shot and 360 for the enemy and so on, we will perform a single rendering for the player, assuming that the service can render 360 different angles. Actually, we could calculate this right now. So if we go back here, let me see. So what do we get here? We have 1280, and actually 1280. Now, if we assume that each one we will set to it 128, okay. So basically, we could render 10 sprites in a row, and 800 divide 128. So we could render 6. So we could render 60 sprites per surface. So if we say we have 360 divided by 60, basically instead of rendering 360 for the sprite of the player, we'll only render 6 surfaces, okay, which is much faster. You know, the player won't feel that. Or as I told you, we could render everything in advance. We just load the files at runtime, and that's it. Very straightforward. And actually, I think we could even demonstrate this right now. Yeah, you know what? Why don't I do it right away? I think I could do it. Let's see, where is it? Where is the code for generating? Where's the sprite here? Okay, so this is the code for this one. So instead of this, I will just say I'm gonna comment this one. Okay, so here I'm gonna say int I angle equal integer of angle. There we go. So we have this an integer, and next we will have a file handle here. Okay, we'll have a file handle, and then all we have to say, we will just say file.read bytes. That's it. I think Let's see, I dot expose. Never mind. ARR equal. Just say byte. Yeah. Wait a second. ARR1. So I will need to convert this into a two-dimensional array. So byte ARR equal new byte 128 by 128. That makes sense. Okay, so now all I have to do is to say for int type is 0, I is smaller than 128 and I plus plus, and for int j equals 0, j is smaller than 128 and j plus plus, ARR of ij equal ARR1 of I plus j multiplied by 128, semicolon, and that should be it. So let's see how fast this one works. See? Okay, so I think this is much faster. Okay, you almost don't feel it. Okay, and so actually pre-loading the values is very fast. Now, one important thing that we must pay attention to is that if I run this one on Android devices, how fast will I be able to load the files here? Okay, here it worked fine, but on Android devices it might be slower. And also, if I change the sprites somehow, I must regenerate these again, if that makes sense. Okay, so I'm just removing this one. I'm just adding a note here. Okay, make sure to run this commented code in case you add new sprites to the sprite sheet or modify existing sprites. Okay, so this is it, and actually I have an Android device connected, and when I tried the previous code, it took about 1 minute in order to show the main image of the game. It was rendering and processing the 360 for the player for a very long time. Okay, but with this one, let me see if it will work well. Okay, it might not be as fast as expected, but yeah, it's a pity I can't show you the actual hardware. Okay, let me see. Yeah, actually the game stopped, and I suppose because simply the assets folder, these files are not being included in the Android deployment. Okay, so I'll have to see what's going on here. So let me see. Okay, actually it might be included already. Seems that it is being included somehow. Anyway, so it was worth a try. So I will see if this one works on Android devices right away, or if it doesn't, I might follow the other method, which is you know, rendering a bunch of sprites on the same service and getting the values of rotation to speed things up. This way we don't have to worry about you know, whether we updated the sprite sheet or added a new sprite to it or moved things. Okay, so that will be all for today. Thank you for watching and have a nice day. Bye bye.